Today's lesson is going to be about simplifying rational expressions. So just like you learned yesterday, when we're looking at rational expressions, there's a couple things we can find out. We can find out the zeros, we can find out domain restrictions, and what we're going to add on to that today is to simplify them, because sometimes we're going to find in factoring that there's actually some terms that we can cancel out. So I'm going to start by looking here on page 2 in your notes. I'm going to write over to the side a couple steps for us to make sure that we're going through for each one of these. And then when you go to do the 10 practice problems in Google Classroom, you want to make sure that you're doing these 3 steps every single time. So step 1, when we're simplifying, we need to factor, and we want to make sure that we factor both the top and the bottom. So that means we're going to factor the numerator, we're going to factor the denominator, not caring at all what happens to each individually. We just want to make sure we get it fully factored all the way down. Step 2, we're going to identify, just like the directions on this page say, identify excluded values. So that's those domain restrictions. And I'm going to put a note here for denominator to equal 0. Remember from yesterday that if the denominator of a fraction equals 0, that's an undefined point. That can't happen. So those are the values that are going to be excluded from our domain because they're just not logical. Then step 3 is going to be to reduce. And what we look for is factors to cancel. So maybe we have a factor of x plus 2 on the top and also on the bottom, so we can cross those out. So let's take a look at problem number 1 and see how this is going to work. So first, we want to start by factoring, again, both the top and the bottom. So if you look at number 1, I see a GCF on the top of x, so we'll take that out in front. So we'll be left with x minus 3 in parentheses. And looking at that, that looks to be about the furthest that can go. So I'm going to say the top is now factored. The bottom, we have x squared minus 9. Factoring technique there's no GCF, but we can do dots. So x plus 3, x minus 3. Now, it might be tempting, but don't reduce the factors first. You need to write domain restrictions. So right before I do anything else, I'm going to write our variable, in this case it's x, is not equal to, and then I want to think, where does that denominator equal? 0. What numbers would make the bottom equal a 0? And you should have found out that that would be -3 and +3. Then now we can cancel out factors that are the same in the top and the bottom. So you're probably noticing that there's an x minus 3 in both places. And if we rewrite without those 2 factors, we're left with x on the top and x plus 3 on the bottom. And in this case, that's as far as we want to go. So actually, both of these 2 things right here are going to be our final answer, the excluded values and then the most simplified version of that fraction. Now, for example 2, we want to start again by factoring the top and the bottom. These 2 are going to take a little bit more time to factor, so I'm going to have you pause the video and come back and check your factoring once you've done so. So take a moment and double check my work, see if your answers are matching, and if you need to, again, pause the video and look at the steps that I took to factor the top and the bottom individually. If not, moving on, we want to second find the domain restrictions. So in this case, our variable is a. What can it not be equal to? Again, we're going to set the denominator equal to 0, and we should find that 3 and -1 are the 2 places that are going to provide problems for us in the denominator. Now, again, we're looking for common factors in the top and the bottom. What you should be noticing is, again, we have a set, a plus 1 in the top and the bottom, and when we go to rewrite it, we now have just 5 a minus 1 all over the GCF of 5 times a minus 3. And we can leave our answer right like that.